And I want to introduce the next speaker to you. It's Stork from Fraunhofer Institute, and he's talking about cloud-based simulations and analytics. And he also has a team with him, and we'll get to know them after his speech.
Yeah, thank you for the introduction. My speech is going to be very short, I think. So I have interpreted my task to introduce you to the topic that you already heard about yesterday in the other slot. The topic is HPC, cloud-based simulation and analysis. Not sure if you hear me all or whether the discussion should be better being done outside the building, outside the room. So you have heard a lot about the possibilities of HPC computing already yesterday, and I thought I'm going to interpret my task here in trying to point out not only the possibilities but also the challenges that we are facing when we talk about HPC and clouds. Okay, so this is the button. So HPC, what is it? First of all, HPC stands for high performance computing. Who has known this before seeing this slide? Okay, many people. What does it allow you to do? HPC computing allows you for solving complex problems. It can be complex physics like CFD, what we've seen, so simulating airflow around cars, for instance. Can be other things like having different media, like in the bioreactor case we have seen yesterday. And it can also allow you to run many simulations in parallel. So either you have many simulations that you want to run in parallel, or you have a big problem, then HPC can show its benefits. So why do you want to do many simulations in parallel? Basically, if you think about industrial applications, the people are interested in optimizing their products. Optimization heavily relies on simulation. So simulation is not a task per se, it's more a vehicle to optimize something. That's actually the whole mission of doing simulations, is to find better solutions. Well, that's the possibilities. What are the other characteristics? HPC is known to be rather expensive, it's knowledge intensive, and it's fast only when it's used in the right way. So you can't just use your standard tool, throw it on an HPC machine and expect that it scales up by a factor of like 1,000, for instance. If your software is not developed accordingly, it's not parallel intrinsically, and the problem is not intrinsically parallel, you won't benefit from HPC. Knowledge intensive, what does it mean? We could also say HPC computing is not very user-friendly. So you need a lot of expertise to be able to run an HPC cluster. I'm not an HPC guy from my own background, so I'm not able to run an HPC cluster myself. If I read our technical documents, I'm rather shocked by all the terminology, by all the different stacks and queues and things that the people need to manage and to be able to actually benefit fully from their HPC resources. So. And HPC is well known, it's rather old, like we have HPC for 50 years probably. On the other hand, we have cloud computing, maybe only for 5 to 10 years. And cloud computing promises to do everything from anywhere, anytime you want it. And you can scale the resources on demand. Also, cloud computing promises you to pay only for what you have used. So you use a service on the cloud and then you pay for your streaming service, for instance, or for uploading data to some kind of data center, of data storage. So Cloud computing is traditionally used for data-intensive tasks. Well, you could say simulation is data-intensive, maybe sometimes, but simulation is rather compute-intensive. And cloud infrastructures are typically not tailored for massively parallel HPC systems in the background. So we rather have two fields with two different histories that we need to integrate to make HPC a practical tool accessible from cloud front ends. So what does it mean, cloud front ends? Cloud front ends are typically web-based. So the remaining challenges, at least some of them, are the software and the hardware per se is not useful for a manufacturing SME if they don't have the knowledge to operate the hardware or the software. So we need these infrastructures that we are talking about yesterday and today to also provide people and knowledge and background to the SMEs to master HPC and cloud computing, or to help them take the first hurdle. And if they learned how to do it, then everything can scale up and can be very easily multiplied. I've talked about the different history of HPC and cloud computing, and the integration is still a challenge, and we are on the way to address it in the Cloudflow project as others also, but it's not yet solved. You have different authentication systems for HPC queues and for cloud computing, etc., etc. So you actually don't want to bother with it, and you want to leave it up to your provider, and they should solve the problem. And an SME doesn't want to care about SSH, POSH, and Bash, and you name it. So there are many technologies and techniques that you need to know to master the integration. Software licensing is still a problem. So you'd like to log into your web front end and then get a license and pay as long as you use it. That's not currently the case for many ISVs. We have heard about some of the big players. They don't support these license models. So you have to call them, ring them up, get a license by email, wait for minutes in the best case, wait for weeks in the worst case before you can start your simulation because you have received your license. And finally, we think about a full process support. Not just having the solver on an HPC and then upload and download the data every time, and it can be tons of data. But the cloud computing idea talks about having the interface anytime, everywhere with you. So that means to have web-based full process support from the modeling stage to the pre-processing stage, the solving stage, the post-processing, the optimization stage. Even start a task, go there with your mobile phone and check whether your solver is actually doing the tasks right. Is it converging, yes or no? So you'd like to have these interfaces, and there is still a way to go. And now we are seeing 3 experiments, how they benefit from HPC and cloud computing, and I'm really looking forward to hear it. I am proud to be a part of IMS, to be able to help the SMEs to take the next step into that direction, into the future. Thank you.